Hello, I am David W. Parker. This is Programming Today I Learned, episode 51 in the 3D Math series. This is going to be looking at quaternions, part 3. We're going to be looking at multiplication here. So this is the code from the math behind episode 29. And so let's go ahead and jump right in. This is basically the entirety of the math we'll be explaining. And actually, we have already explained the math, but this is the code behind that episode. So let's go ahead and take a look at that episode real quick. As you can recall, we can basically use this definition for multiplication. This is us replacing i's and j's respectively, which ultimately ends up with this simple equation right here. And that is the same as this exact code here. With this, we'll be returning a new quaternion after the multiplied from this to that. So this is the equivalent to this formula down here. With the w minus the dot product of v and v2, and then this equation down here with w1 v2 plus w2 v1 plus the cross product of both of the vectors. So pretty simple. We can go ahead and look really quick here. We have a couple of multiplication examples out where if we're multiplying by the identity within each of these, we obviously give back the initial quaternion. So that holds true. We have the fact that multiplication is not commutative. So looking back here, we could see that ABC is not commutative because AB is not the same as BA. So we have Q times Q3 here printed out, and then Q3 times Q4 printed out. You can see that those are clearly different, so that holds true. Also of note is the fact that the magnitude of the products of the quaternions are equal to the quaternion, the product of the magnitudes. So magnitude of the quaternion product is equal to the product of the magnitudes. So we can see that here we clearly state that we have the magnitude of each of these from the respective ones. It's the same here. As well as the fact that, excuse me, it's these here, and that the Q4 from above, its magnitude is the same as the magnitude of these individual ones. Also note that when you normalize them and you compare the magnitudes, it's also the same here. So obviously floating point errors and all whatnot, you're going to end up with stuff like this as opposed to a single one when you're dealing with unit vectors. So just make sure you pay attention to that in your language of choice. This is obviously JavaScript, so it has all sorts of funkiness with itself. So that's it for this episode. If you like what you saw, go ahead and subscribe and give a like. Share on social media if you will. Go to ProgrammingTIL.com and sign up for our newsletter. And have a great one. Thanks.